Hello student, my name is Dr. Sevinc Fətullayeva. I'm assistant professor at the General Hygiene and Ecology Department. Today we continue study about very important part of hygiene of nutrition, lecture 8, topic name, the hygienic estimation of nutrients, their biological and nutritious value. The term food material in synonyms with the expression articles of food, thus bread, meat, egg, milk are spoken of as food material. The term foodstuff is sometimes popularly or commercially used as synonyms with articles of food, but also is used in a somewhat different sense to mean the stuff that foods are made of, or in the term which we have been using, the substance of which the food material are composed. Thus, the protein, foods, and carbohydrates, and the various organic and inorganic compounds of phosphorus, potassium, iron, which occur in food material, are foodstuff in the sense this is synonymous with nutrients, contents of nutritious nutrition. First group, nourishing element as protein, fats, carbohydrate, vitamins, minerals, water. Tertiary element, organic acids, ketones, ether, and others. Anti-nourishing element, anti-amino acids, anti-vitamin, anti-minerals. Foraging element as radioactive element, heavy metal, salts, nitrosamine, and others. Thus, main food material include protein, fats, carbohydrates, minerals, vitamins, and water. The nourishing and anti-nourishing elements are the natural component of food. Protein. One of the most important components of the food is protein. Sufficient and high quality protein in the diet provides the best condition for the normal function of the body and its high efficiency. Is the protein part of the diet the source of growth, repair, and renovation of the protoplasm of cells and tissue? Inadequate intake of protein affects the function of all systems. First of all, surface enzyme system, closely related to protein synthesis of hormones, reduce the protective function of the organism in connection with a reduction in the production of antibody, as decrease the biosynthesis of globulins, gamma globulin. It reduces the child's body resistance to respiratory and infection disease, intestinal disease. Creation of biological value of protein is the amino acid score, is percentage of quantity of irreplaceable amino acid in protein of a product quantity of the same amino acid in standard protein with ideal amino acid. By next scale. Amino acid composition of protein. There are 6 available amino acids which cannot be formed by the body. The biological role of the 3 most deficient of essential amino acids. For example, among the most important for the human organism are essential amino acids tryptophan, lysine, and methionine. The optimal ratio of these amino acids in the daily diet is 1:3:3, which corresponds to their ratio in human milk and average amino acid composition of the human body. If the amino acids enter in another ratio, the protein synthesis in the human body is at the level of the amino acids, which is less likely, and the remaining amino acids excretion. Property: different amino acid in human organism. Methionine is involved in fat metabolism, control phosphatase fat exchange, being one of the best lipotropic substances, prevents adiposity of liver. Methionine is the best donor of methyl group in the synthesis of choline, anti-sclerotic factor. Methionine prevents heavy losses in radiation exposure, and the effect of bacterial toxin contributes to a more complete manifestation of the action of vitamin B12 folic acid. Methionine is a good source of milk protein, casein, which contains up to 3% methionine. Much of it is contained in cod proteins, eggs, and meat in proteins of animal products. Lysine is closely connected with the formation of blood, which has likely reduced the number of red blood cells and hemoglobin. In addition, when there is a violation lack of calcification of bone, depletion of muscles, lysine is necessary for the growth of young organisms. The main source of milk protein is lysine. It contains 1.5% of lysine that is also in meat animals. Tryptophan is an amino acid essential for synthesis of nicotinic acid in the body, a P vitamin. Hemoglobin, formation of serum proteins, is a growth factor. The lower the age, the greater the need for tryptophan. However, tryptophan is quite difficult to deal and is sufficient amount because 100 grams of meat eggs it contains only 0.2 grams. In the milk is tryptophan in the albumin, which when heated above 70% degree, denatures and precipitates on glassware, while the gas is lost and the tryptophan. Therefore, it's important to process the milk so that there was no loss of albumin. Ideally, of course, drink raw milk from healthy cow. Histidine has a main role in the hemoglobin formation and in conditioned reflex activity. Phenylalanine is related to GOTA and adrenal system. Isoleucine is a component of a body protein except hemoglobin. Threonine, the lack of its cause of growth retardation and weight loss of animals. Betaine, the lack of its cause of growth retardation and disorders in kidney and gut. The protein deficiency causes. At protein deficiency in the diet, the morphology change were observed in bone marrow cells, and this entails a violation of the process of hematopoiesis and morphological change in the composition of the blood, as well as reducing the oncotic pressure. Reducing the amount of protein in the diet affects the conditioned reflex activity, causing the weakening of the excitatory and inhibitory process. Chronic insufficient intake of protein leads to deep disturbance of liver function, causing the development of fatty liver. It is established that in order to prevent fatty liver, choline is needed, which can be supplied ready-made with products, phosphatid, or can be synthesized in the body with the assistance of the amino acid methionine. Methionine also comes with complete protein of animal origin. The disease most often affects infants, 6-8 months. The mortality rate 30–50% when administered in the diet the high grade of protein disease carried. Insufficient supply of protein with food is reflected in the cause of mineral metabolism. It was found, for example, that a violation of phosphoric calcium metabolism in children may be linked not only to the lack of the salts, vitamin D, and protein deficiency, and at the same time there is a decreased bone growth and change in their chemical composition. This diet to decrease activity of the enzyme phosphatase, an important factor in bone formation. There is evidence that protein deficiency can lead not only to subsequently stunting of the first years of life, but also to a psychomotor delay of development. With regard to the effect of protein deficiency on vitamin metabolism, in this area there is a lot of work pointing to the close relationship between the two exchange. It's known, for example, that with a deficiency of protein described synthesis of vitamin PP in the body because its synthesis is linked to the amino acid tryptophan. The observation have shown that if people impure a large proportion falls to a product such as corn, maize, a protein that contains a small amount of tryptophan in the diet, and if not enough dairy products, the population often appear pellagra disease. As lack of protein in the diet increase the body's excretion of vitamin C, increase urinary excretion of riboflavin B2 and development of araboflavinos is closely connected with provision in protein body. With long-term insufficient intake of protein with food in children develop the disease called kwashiorkor disease, nutritional dystrophy, nutritional marasmus. What is necessary to have the amount of protein in the daily diet? Protein requirement depend on age, sex, national work, climatic and national future. A particular difficulty is to determine the optimal protein norm and value of permissible reduce it without compromising human health in a variety of conditions of life and activity. The most thoroughly studied and developed in detail dates is the minimum a person needs is protein that is associated with the deficit in a specific protein value as a food substance and the presence of proven metabological appropriate. For this purpose, a method for determining the nitrogen balance at certain minimum receive a protein dietary nitrogen equilibrium is established. The amount of nitrogen excreted by the different ways it becomes entered with food. If the amount of protein in the diet is not sufficient, then the state is set to a negative nitrogen balance, indicating that the flow rate exceeds the intake of tissue protein with their food ration. According to the physiological nutritional standard, the total amount of protein in the diet of children should be twice the number compared to prevailing nitrogen balance and nitrogen equilibrium, and for adults to 1.5 number. Minimal amount of protein should arrive in an organism for providing early nitrogenous balance, 56 grams. For preschool children, 53-69 grams. For school children, 77-98 grams. For adult population, 83-118 grams, depending on their profession. In general, at the expense of protein should be provided 11-13% of the calorie diet, along with overall amount of protein and its normalized amounts of animal protein because they are complete proteins. It contains all of the essential amino acids, valine, histidine, isoleucine, leucine, methionine, tryptophan, phenylalanine, and others. Proteins of animal origin must be at least 60% of children and at least 55% for adults. For source of valuable protein in percentage, meat 16-22, fish 40-20, bird 16-24, egg 12.5, milk 3.4, and others. The product's plant's origin, next P 23.4, carrot 1.5. Less than high grade amino acid composition of protein are the products of plant origin. However, inferiority of the amino acid composition of vegetable proteins is compensated with food, mixed food, and especially dietary rational selection of a variety of plant and animal products. Moreover, among the plant products have legumes, which contains a large amount of protein. Protein in this product have sufficient, especially valuable amino acids such as tryptophan, lysine, methionine, and soy contains these amino acids even more than meat and methionine is as much in the carb. Biological function and value of fats. Fats. A substance in the body performs mainly energy function. In this respect, fats superior to all other food components, proteins and carbohydrates, as allocated in 2 times more energy when burned. 1 gram fats equal 9.3 kilocalorie forms. However, the biological significance of fat is not confined only to their energy function. Fats involved in plastic function as a structural part of the cells and their membrane system. Fats improves the flavor of food, acting as flavoring substance and improve its nutritional value, creates a high degree of saturability. However, even more important is the fact that only together with fats in food body receives a number of biologically valued substances, fat-soluble vitamin, phosphatids, lecithin, polyunsaturated fatty acids, sterols, tocopherols, and other substances having biological activity. In the body, fats is in 2 forms: a structural, protoplasmic, and reserve in the fat depots in the subscretional fat layer in the abdominal cavity, gland, above the kidney fat. Quantity of protoplasmic fat bodies and supported in tissue at a constant level and is not changed even during starvation. Degree accumulation of reserve of fats depends on the character of food, level of energy consumption, age, activity of the endocrine glands. Heavy physical work, some of the disease, insufficient food may reduce the amount of reserve fat. Moreover, vice versa, excess food, hypodynamia, reduced gonadal function, thyroid gland lead to increased fat reserve. Inadequate intake of fat can lead to disorders of central nervous system due to violation directional flow of nerve signals, where weakening of the immunological mechanics, change in the skin, where they serve a protective role, protected from hypothermia, increase elasticity, and prevent dryness and clotting, disruption of the internal organ, especially kidney, which protect from mechanical damage. Classification of fats. Divided next group: trifats, lipids, phospholipids, and sterol. Trifats, fatty acids, glycerol. The fatty acids divided two groups: saturated and unsaturated fatty acid. Saturated, for example, palmitic acid. Unsaturated, linoleic acid. Second group, lipids, phospholipids. Phospholipids, structural component of fats, precipitate in fat transportation. And third group, sterol, aromatic alcohol, include cholesterol, structural component of all cells. Food fats will consist of ethers of glycerin and the high fatty acids. The major component determining property of fats are fat acids. They share on saturated and non-saturated. The greatest value on a degree of distribution in foodstuff and to the property is represented with the oil, stearin, palmitic, which in structure of animal fat and make up to % of fat acids of the mutton and beef fat, causing high temperature of fusion and the warm permissivity. Of unsaturated fatty acids, greatest importance have linoleic, linolenic, and arachidonic, collectively known as vitamin-like factor P, to common in the first liquid fats, oils, and fish fat. The vegetable oils, sunflower, corn, olive, linseed, they contain up to 80–90% of the total fatty acids, Of greatest importance is the polyunsaturated fatty acids are small amounts in some animal fats in vegetables oils. The biological role of polyunsaturated fatty acids precipitate a structural element in phosphatide of lipotrophy of cells, composed in the connective tissue neurons of nervous tissue. Polyunsaturated fatty acids affect cholesterol metabolism by stimulating its oxidation and isolation of the organism and with forming esters which do not fall out of solution. Polyunsaturated fatty acids have a normalizing effect on the blood vessels walls, increasing their alignment and strengthening them. Polyunsaturated acids stimulate the body's defense mechanism, increase resistance to infection disease, effect of radiation, and also are in the metabolism of B vitamin, thiamine, and pyridoxine. Also, this lipotropic action prevent fat liver, stimulate the body's defense mechanism, are important in the prevention and treatment of disease of the cardiovascular system. The biological significance of polyunsaturated fatty acids differently, which the largest active arachidonic acid is less than linoleic and linolenic. The need for polyunsaturated fatty acids is 3-6 grams day. Of the content of polyunsaturated fatty acids, dietary fats are divided into three groups. First, fats rich in polyunsaturated fatty acids. Fish oil include 30% arachidonic, vegetable oils, linseed, sunflower, corn, soy. Second, with an average content of polyunsaturated fatty acids, fats, pork fat, goose, chicken fat, polyunsaturated fatty acids content not exceed 5-6% in third group, mutton and beef fats, sometimes of margarine. Especially higher biological activity of different liver oil of fish and marine mammals. An indicator of the biological value of fat is also the presence of vitamin A, D, E. Therefore, butter contain this vitamin, despite low levels of polyunsaturated fatty acids, is a product of high biological value. The biological role of phosphatide. The composition of fat include phosphatides. The highest biological activity have lecithin, cephalin, sphingomyelin. In complex protein, they are members of the nervous tissue, liver, cardiac muscles, gonads, precipitate in the construction of cell membranes, determine their degree of permeability of fat-soluble substance, precipitate in the active transport of specific substance and complex ions in and out of cells. Phospholipids are involved in blood clotting, contribute to better use of protein and fat in the tissue, warms fatty infiltration of liver. Phosphatides, lecithin mostly, play a role in prevention of atherosclerosis, prevent the accumulation of cholesterol in the vessel's wall, promote cleavage and removal from the body. Thanks to these properties, phosphatides belong to the lipotropic factor. The need for phosphatides is 5-10 grams. Phosphatides contained in the egg yolk, brains, liver, and also in meat, cream, sour cream, and others. From herbal products, by significant contents are characterized largely and refined oil, often used as a source of soy lecithin, phosphatides, or products phosphatide concentrate, sunflower and soya used to refine vegetable oils and margarine, and obstacle to the use of these concentrates are unsatisfactory their flavoring property, rapid oxidation, and rancidity. The sterols. The fat composition comprises fat-like substance, sterols, water-insoluble compounds. There are phytosterols and zoosterols of animal origin. Phytosterols have biological activity and important role in normalization of cholesterol and fat metabolism. The most important representative of a phytosterol is sterol, especially beta-sitosterol, which insoluble complex with cholesterol prevents the absorption of cholesterol in the intestine, which is of great importance in the prevention of cirrhosis. Beta-sitosterol is contained in spinach, sunflower oil, soya, olive, corn and cotton oils. Important zoosterols is it comes into contact but can be synthesized from intermediate metabolism of carbohydrates and fats products. Cholesterol plays an important physiological role as a structural component of the cells. It is the source of bile acids, hormones, sex and adrenal cortex, a precursor of vitamin D3. However, considered as a factor in the formation and development of atherosclerosis. The blood cholesterol bile is retained in the form of colloidal solution binding to phosphatase and saturated acids protein. At violation changing of this substance or the lack of cholesterol precipitates a small crystals on the walls of the blood vessels. Bile duct promotes occurring of atherosclerotic pleasure vessels, the formation of gallstone. However, there is study that daily cholesterol in atherosclerosis and the increased consumption of animal fats, saturated fatty acids, soil. The role biosynthesis in the liver with the dominance of saturated fatty acids, cholesterol bias is increased with the predominant polyunsaturated fatty acids reduced. Cholesterol metabolism are important vitamin C and B12 and folic. The need for cholesterol equal 0.5 1 gram day. Almost cholesterol is contained in all animal products. The largest number is in the brain, chicken egg, duck egg, cheese. Animal fats, source of vitamin A, D, E, and F factor. Butter contains vitamin A and E. Vegetable oils, vitamin E and F factor. The biological role of tocopherol. The fat composition comprises tocopherols, which are found in vegetable oils and present 7 kinds: alpha, beta, gamma tocopherol, and others, and all which alpha, beta tocopherol possess vitamin E activity and the other are powerful antioxidants. The most important feature of tocopherol is the ability to normalize and stimulate muscles activity. Degree of cover the body, tocopherol is important for the normal function of the heart muscles. Increasing use of tocopherols obtained at high physical activity to improve muscle performance. An important feature of tocopherol is the ability to increase the accumulation of internal organs of the fat-soluble vitamins, especially retinol. They are one of the most active agents that promote the conversion in the body keratin retinol, vitamin A. If they consider that 75% of the demand is covered keratin to retinol, and when the latter is difficult to digest, it becomes clear the great importance which have tocopherols to provide retinol body. Source of vegetable oils are tocopherols and sunflower oils is particularly valuable because it contains only alpha-tocopherol, 100%, which has vitamin activity. A significant amount of tocopherols found in egg yolk, butter, margarine. Inadequate intake of fat can lead to a number of central nervous system disorders, weakening all the immune biological mechanism, pathological change in the skin, kidney, and eyes. And without fat diet, animal stops growth, falling weight, disturbed sexual function and water metabolism, reduce the production of steroid hormones in the adrenal glands, weakens the body's resistance to adverse factors, shortening lifespan. However, for many diseases, it's necessary to limit the amount of fat. Obesity, pancreatic disease, chronic colitis, disease of the liver, diabetes, acidosis. Daily norm of fats for men group on intensivity work equal 93-103 grams. This slide includes requirement in fats for children and adolescents, dependent on the age. From what has been said above, it will be clear that the various digestible carbohydrates of the food, having been split by the digestive enzyme to monosaccharide, are absorbed into the blood, and surplus is stored temporarily in the form of glycogen, chiefly in the liver, to some extent in the muscles. The glucose which circulates in the blood is burned in the muscles and other active tissue as fuel, the burned glucose being constantly replaced by new glucose derived from the stored glycogen. When more carbohydrate is received than is burned, the surplus is stored as glycogen, but only to a limited extent. The total amount of glycogen which the human body can store being estimated at less than 1 pound or only about as much carbohydrate as might be contained in the food of one day. Carbohydrates belongs exclusively important role in nutrition. Carbohydrates are a good energetic material. Plastic function of carbohydrate is low, but they are part of some tissue and liquids of body. The regulatory function of carbohydrates is where they counteract the accumulation of ketone body in the oxidation of fats. In cause of violation of carbohydrate metabolism, diabetes develops acidosis. Carbohydrates give the food a feeling of sweet taste, turn off the central nervous system. Carbohydrates have biological activity, heparin to prevent blood clotting in the blood vessels. Hyaluronic acid prevents bacterial penetration through the cell membrane. The role of carbohydrates in the defense reaction, especially in the liver. Glyceronic acid connected with toxic substance forming non-toxic esters, which are soluble in water, removed from the urine. Classification of carbohydrates. Carbohydrates divided next three groups: monosaccharide, disaccharide, and polysaccharide. Monosaccharide: glucose, fructose, galactose; disaccharide: sucrose, lactose, maltose. Polysaccharide includes starch, dextrin, glycogen, inulin, and others. Carbohydrate foods are divided into simple and complex. The simple carbohydrates include monosaccharides, glucose, fructose, and disaccharide, sucrose, lactose, and maltose. For complex carbohydrates are polysaccharides, starch, glycogen, pectin, cellulose. Simple sugar are absorbed very quickly and burned quickly, releasing energy. Athletes to maintain high but short-term operability successfully use this property. For example, sprint. The biological role of monosaccharides. Glucose, the major structural unit from which is the built polysaccharides, starch, glycogen, cellulose. Glucose is a part of these saccharides, sucrose, lactose, maltose. It's rapidly absorbed into the blood and its high physical activity is used as an energy source. Glucose is involved in the formation of glycogen, nutrition of brain tissue, working muscles. Glucose is easily converted into fat in the body, especially when it is excessive intake. Glucose source, fruits and berries, and honey, where glucose contain up to 37%. Fructose has the same property as the glucose, but is slowly absorbed in the intestine and entering the blood levels it rapidly, without causing saturation of blood or sugar. Its fructose property is used for disease of diabetes. Fructose is much faster than glucose is converted to glycogen. Whey is better tolerability as compared to other sugar. Fructose is almost 2 times sweeter than sucrose, 3 times sweeter than glucose. If the sweetness of sucrose taken as 100, the amount from fructose sweetens 173, glucose 74, invert sugar 130, maltose 32.5. High fructose sweetness allows using it in a small amount that is of great importance for food ration with caloric restriction. Source of fructose, fruits and berries. Honey, eat watermelon, melon, apple, pear, blackcurrant, fructose, predominance over glucose. The biological role of disaccharides. Sucrose in the gastrointestinal tract breaks up into glucose and fructose. Sucrose, the most common sugar. Source of sucrose, sugar beet and sugar cane. Sucrose content in the sugar sand 99.7%, the refined sugar 99.9%. Sucrose has the ability to turn into fat. Excessive intake of carbohydrate in the diet causes a disturbance of lipid and cholesterol metabolism in the human body, has a negative impact on the status and function of the intestinal microflora, increasing the intensity of the putrefactive process in the intestine, leading to the development of intestinal meteorism. Excessive amount of sucrose in the diet of children leads to the development of dental caries. Lactose, next disaccharide, carbohydrate of animal origin. Hydrolysis is cleaved into glucose and galactose. Hydrolysis is slow, limiting the fermentation process, which is of great importance in the diet of infants. Intake of lactose contributes to the development of lactic acid bacteria that suppress the development of putrefactive microorganisms. Lactose is the least used for the formation of fat and excess does not decrease blood cholesterol. Source lactose, milk, and dairy products in which the content of the disaccharide can reach 4–6%. Starch is polysaccharide. Its share in the diet accounts for about 80% of the total amount of carbohydrates consumed. The starch in the human body is the main source of glucose. Starch is the main part of the carbohydrates of bread and bakery products, flour, various cereals, potatoes. Pectin substance. There are pectin and protopectin. Protopectin compounds pectin and cellulose, is found in plant cell walls, is insoluble in water. The rigidity of the immature fruit due to a large content of protopectin. In the process of maturation, protopectin cleaved and fruits become soft at the same time. They are enriched with pectin. Pectin is component of the cell's sap and is characterized by good digestibility. Pectin substance has the ability to inhibit the activity of putrefactive intestinal microflora. Pectin is used in preventive nutrition for persons working with lead and other toxic substances. Pectin substance contained in apricots, oranges, cherry, apples, pear, pumpkin, carrots, and others. Average need of carbohydrates is 400–500 grams a day, which is towards protein and fats 1,4 for children and 1.25 for adults. Thus, the total number of carbohydrate starch should fall 350–400 grams on mono and disaccharide 50–100 grams on nutritional ballast substance cellulose and pectin equal 25 grams. Biological future some minerals material. Mineral substance are essential nutrients which must necessarily arrive in an organism. The value of mineral substance in the human diet is very diverse. In the body, mineral substance include a complex of substances constitute living protoplasm cells in which the basic substance is a protein. Minerals are part of all intercellular and interstitial fluid, providing them with the necessary osmotic property. Mineral substance in a large quantity include in the supporting tissue, bones and skeleton, in the tissue such as teeth, which is necessary and hardness and special strength. Mineral elements are part of some endocrine glands, iodine in the thyroid, zinc in the pancreas and tissue of the gonads. Minerals are part of some complex organic compounds, iron of hemoglobin, phosphorus a phosphatide composition. Minerals as ions involved in the transmission of nerve impulse. Mineral substance provide blood clothing. Classification of mineral material. First group, alkaline mineral material. Second, mineral material of acid origin. Third, bare trace mineral. Especially important are minerals for the growing organism. Increased need for rare at children explained by the growth and development process are accompanied by an increase in cell mass, skeletal mineralization, and this requires systematic supply in child organism a certain amount of mineral salts. Mineral substances enter the body mainly with the food products. The elements found in food products can be divided into three groups: macroelements, microelements, and ultra-microelements. Macroelements, elements that are present in product in large quantity, 10 and hundreds of milligrams%. These include phosphorus, calcium, potassium, magnesium. One of the most important minerals is calcium. Calcium, a constant component of blood, is involved in the clothing of blood, is part of the cellular and tissue fluids, cellular nucleus, and plays an important role in the growth and activity of cells or the process involved in the regulation of the permeability of cells membrane or nerve impulse transmission process, muscle construction. It controls the activity of some enzyme. Basic calcium importance is its precipitation in the formation of the skeleton of bones, where it is a major structural element. The calcium content in bone reaches 99% of the total amount in the body. The need for calcium is especially high in children, which take place in the body bone form process, as well as women during pregnancy and while breastfeeding. Prolonged lack of calcium in the diet leads to disruption of bone formation, to emergence of rickets in children, osteoporosis, and osteomalacia in adults. Slide contains information about contents of macroelement calcium in different foods. Higher percentage of calcium included in the milk and dairy products. Daily requirement of calcium for adults: 800 mg, for children 1900 mg, depends on age. Next macroelement: phosphorus. Phosphorus involved in metabolism process of carbohydrates, fats, and protein. Is an element within the structure of the major organic compounds and plants of a nucleic acid and some enzyme. About 80% of the phosphorus is included in the bone. About 10% is in the muscles tissue. Daily requirement: 1200 mg per day. The body's need for phosphorus is increasing in low-protein areas with food and especially with an increase in physical activity. Slide include information about contents of phosphorus in different foods in 100 grams of foods. Next group, microelements. Microelements, elements present in food products, is amount of less than 1 mg%. Microelements: fluorine, iodine, cobalt, iron. Iron. The average iron content of a healthy adult is only about 4 grams, and yet this relatively small quantity is vitally important. About 2/3 of iron in the body is present in the blood mainly as hemoglobin, and approximately 3% is present as myoglobin. The majority of the remainder is storage iron, which is found in the liver, spleen, bone marrow, and muscles in the form of ferritin or hemosiderin. Additional minute quantities exist in the respiratory enzyme and in iron-binding protein of the plasma. The main function of iron is vital role in the transfer of oxygen at various sites in the body. Women of childbearing age must, however, include the iron loss during menstruation and childbirth and meet the additional requirement of pregnancy and lactation. Children have relatively higher needs because of their rapid growth, which not only increase their body size, but also their blood volume. Source of iron. Iron is present in a great variety of foods, of both plant and animal origin. Rich food sources for iron include meat, especially liver, egg yolk, and pulses such as beans and peas. However, many other common foods such as green leafy vegetables, whole grain and enriched cereals, vegetables and fish are good sources of iron. Milk, both humans and cows, contrary to the notion that it is the perfect food, is a poor source of iron. For example, cheese, 6,400 mg, egg, 210-250 mg, and others. The next very important microelement for human health, iodine. The body of an average adult contains about 30 mg of iodine, of which about half is present in the thyroid gland. Iodine is essential for the formation of thyroxine and 3-iodothyronine, the hormones of this gland. Iodine is present in rock and soil that through the ages much has been washed into the sea. Man gets his iodine from food and from water, which vary in amount according to the iodine content of their source. Thus, there are water with a high content of iodine and others with negligible amounts, and the same foodstuff growth in different soil has a different iodine content. Seafoods on the whole are rich in iodine, and dairy products, egg, and some vegetables may be good source. Daily requirement. It has been suggested that 1 microgram of iodine per kilogram body weight is an adequate intake in the human. However, growth in children and women during pregnancy and lactation have increased needs. Deficiency. A deficiency of iodine leads to the development of goiter, but there are several other causes of goiter besides iodine deficiency. Next, potassium. What has just been said of magnesium is usually true also of potassium. Potassium is so widely and abundantly distributed among natural food products of both plant and animal origin that through it plays a very important role in our body, we can normally trust to chase that we will receive enough of in our food. Zinc. Our body needs zinc for many different functions, which include protein and carbohydrate metabolism, bone healing, growth, and vision. Zinc is vital to 200 enzymes. Zinc metal enzymes are found virtually in every metabolic pathway. Zinc is component of insulin, involved in formation of bone tissue, healthy skin, vitamin A metabolism, phosphorus absorption, linoleic acid transformation. It reinforces the immune system. A too high intake may compress the absorption of kappa. Ultra microelement. They contain in products in milligram percent. This is gold, lead, mercury, and radium. Vitamin. Vitamin are organic food substance with low molecular weight and need for the normal activity of the organism. In the body, presence of small quantity necessary to correct growth and health. Most of them are not produced in the body, but some of vitamins may be formed in the body, like vitamin B, vitamin D. The main function of vitamin, most of them are integral part of coenzyme. They get part in biochemical reaction at tissue level, tissue oxidation. They involved in metabolic reaction. They preserve hormones from destruction. They get part information of enzyme. Chemical classification of vitamin: water-soluble, fat-soluble, and provitamin. Water-soluble vitamin include B group vitamin, vitamin P, PP, C, biotin. Fat-soluble A, D, E, K, provitamin B15 and O. Functional classification: stimulation of body resistant, anti-hemorrhagic, anti-anemic, anti-infection, essential for vision, antioxidants. Clinical situation category include hypervitaminosis causes, hypervitaminosis, and avitaminosis. Hypervitaminosis or high percentage vitamin in human organism causes toxicity. Hypervitaminosis, deficient quantity of vitamin in daily ration. Avitaminosis, the absence of vitamin in daily ration. Hypervitaminosis etiology: external factor, food problem, for example, storage time, cooking method, low content of vitamin in food, season, spring and autumn, increasing hypervitaminosis between population, poor knowledge of food value. Internal factor causes hypervitaminosis, problem with absorption and intercurrent infection, protozoa causes hypovitaminosis, the physiological condition of the body. Increase of vitamin requirement in pregnancy. Slide contains information about vitamin deficiency for different types of vitamin. For example, vitamin B1 thiamine deficiency causes disease polyneuritis or beriberi disease, PP pellagra disease, C vitamin scurvy, B12 different kind of anemia, and others. Short information about different water-soluble vitamin. Vitamin B1, thiamine. Main function, take part in the tissue metabolism. Thiamine is present in the nervous cell, is implicated in the synaptic transmission of nervous impulse, take part in carbohydrate metabolism. Main source of vitamin B1, bread, beans, rice, vegetables, liver, and egg. Some part of vitamin is lost with water by washing or cooking. Daily requirement is 1-3 milligram. The daily dose depends on age, sex, and type of physical activity. Vitamin B1 deficiency, thiamine deficiency, is still an endemic problem in certain areas of Asia where rice, especially polished rice, is the main food in diet of population. Quantity of thiamine is polished rice is a poor diet to boiling and drying rice before milling. In the process of cooking, about 25% of thiamine is lost. The thiamine deficiency disease is called as beriberi disease. Clinical types of beriberi: acute infantile beriberi occurs in breast-fed babies when the mother is deficient in thiamine. Chronic beriberi mainly among adults, cerebral beriberi, mental and eye disorders. Water-soluble vitamin, vitamin PP, nicotinic acid or niacin. It's a colorless substance resistant to the action of the acid, alkaline medium, UV rays, and temperature. Function. It's a component of the respiratory coenzyme, take part in synthetic and redox reaction. Food source. Niacin naturally is present as nicotinic acid in cereals, grain, beans, spinach, meat products. For example, 100 grams of liver contains 6.8 milligram vitamin PP. Recommended daily intake is 16-28 milligram for men and 14-20 milligram for women. Niacin deficiency is presented as pellagra disease or disease of Friedel. Skin, main 6 dermatitis, skin lesion, dementia, disorders of peripheral nervous system. Very popular today among population with a soluble vitamin, vitamin C or ascorbic acid. Ascorbic acid is a white crystalline substance, very highly soluble in water and readily oxidated. It is not affected by light, but is destroyed by excessive heat, especially in an alkaline solution. Vitamin C has many functions in the body. The recommended dietary allowance of the Food and Nutrition Board summarizes ascorbic acid role in the following metabolic system. Oxidation of phenylalanine and tyrosine via parahydroxyl phenylprevite, hydrochylation of aromatic compounds, conversion of folate to folic acid, regulation of the respiratory cycle in mitochondria and microsomes, hydrolysis of alkyl monocytoglycosides, development of odontoblasts and other specialized cells including collagen and cartilage, maintaining the mechanical strength of blood vessels, particularly the venous. Vitamin C takes part in production of fibrous tissue collagen, metabolism of amino acids, fats, and carbohydrates, biological oxidation, calcium metabolism, formation of hemoglobin and DNA and RNA. This slide includes information about contents of vitamin C in different food, milligram in 100 grams of products. Blackcurrant, citrus include very high percentage of C vitamin. Also, C vitamin include and contains in the different vegetables, tomatoes, apple, cabbage, and nuts. Daily requirement C vitamin for children up to 75 milligram, for adult up to 100 milligram. Deficiency C vitamin leads to the disease scurvy. There is some evidence that a subclinical deficiency of the vitamin, not sufficient to cause any of things of scurvy, may result in slow healing of wounds or ulcers. Therefore, persons undergoing surgery or following trauma or with persistent ulcers who are suspected of having a low intake of vitamin C should have a vitamin C-rich diet or receive supplemental ascorbic acid tablets. Claims have been made for the efficacy of large doses of ascorbic acid in preventing the coma. Controlled trials have shown that the vitamin has no benefit in this regard. Toxicity with vitamin C. Very high doses of ascorbic acid can be taken without the development of any toxic effect. High doses of vitamin C may cause hypoglycemia, oxalate stones formation in the urinary tract, symptom of hypovitaminosis registered every season in the winter and autumn season, weakness, weight, loss and petechia, gums bleeding, and gingivitis. Example of water-soluble vitamin, very interesting and very important for human health, biotin. Biotin is essential in many enzyme systems in animals and man. The vitamin is present in many foods and is synthesized in sufficient quantity by human intestinal bacteria to satisfy normal requirements. Daily requirement 150-300 microgram and amount provided by most diet. Raw egg white contains a substance called a white in which when combined with biotin makes it unavailable to the body. Biotin presence egg white injury with a biotin deficiency that can be produced in animals fed a diet high in egg white. Deficiency. Spontaneous biotin deficiency is an extremely rare condition occurring occasionally in an individual who for some strange reason has consumed a diet consisting mainly of raw egg. It has also been reported in the infants where intestinal tract has been cleared of biotin synthesizing bacteria by ingesting use of sulfa drug or antibiotics. The presenting signs of biotin deficiency is an exfoliative dermatitis which responds to biotin. Experimental biotin deficiency is volantis, led to fatigue, depression, anorexia, muscle pain, nausea, signs of neuropathy, and an erythematous scarring dermatitis. The symptoms and signs disappeared when biotin was administered. Fat-soluble vitamin also very important for human health. Fat-soluble vitamin A, D, E, K. Vitamin A, retinol. It is an alcohol and fat-soluble vitamin. Low pH and light reduce its activity. Vitamin A is stable if the temperature is below 100 degrees. Low temperature and alkaline medium tends to preserve it. In the same time, long-term heating and contact with air slow destroys. Function of vitamin A. Necessary for night vision, formation of rhodopsin of the retina, required for growth and development, now as vitamin of growth, synthesis of glycoprotein, anti-infection, required for epithelial cells, anti-xylophthalmic, metabolism of minerals and cholesterol. Food source of IA vitamin, animal fat, milk, liver, egg and fish liver. Vegetable carotene source, dark green vegetable as spinach, and yellow fruits and vegetables as pumpkin, mango, and carrot. In human organism, carotene converting into vitamin A, happiness in inside walls of intestine. 6 parts of beta-carotene are equivalent to 1 part of vitamin A. Daily requirement for children 4-500 micrograms, for adults 800-1000 micrograms. Vitamin A deficiency, night blindness, xerophthalmia, drying and thickening of the cornea, hyperkeratosis of the skin, growth retardation, low birth weight. Hypervitaminosis is available even in causes when vitamin A gets in organism with food, A vitamin enriched products. Acute toxicity symptom, drowsiness, headache and irritability. Chronic toxicity syndrome, alopecia, dry skin, headache, weakness and others. Next, fat-soluble vitamin, vitamin D. It had been postulated that rickets was a nutritional deficiency disease, and for many years prior to any knowledge of the vitamin, cod liver oil had been successfully used in treatment. It was not until 1990 that a British scientist, Mellamby, using puppies, demonstrated conclusively that the disease was of nutritional origin and that it responded to a vitamin present in cod liver oil. This led to some confusion because it was already known that cod liver oil contained vitamin A. In 1922, Mr. Coulomb isolated a second fat-soluble vitamin from cod liver oil and called it vitamin D. There are 6 types of vitamin D, characterized by the difference of the carbon change and by degree of saturation. Is a thermal, stable, fat-soluble vitamin being mainly in 2 forms. D. Second, ergocalciferol in yeast and D3, cholecalciferol, produced in human skin by irradiation of UV rays medium weighs from 7-dehydrocholesterol. Food source, vitamin D, butter, egg, liver, milk. The best source are fish liver oils. Function of vitamin D, prevention of the rickets. It takes part in absorption of calcium and phosphorus and their storage in the bones. Prevention of the osteomalacia, absorption of calcium and phosphorus in the gut, directly participating in both calcification. Vitamin D deficiency may cause rickets in children, bones deformation, and osteomalacia in adults. Recommended daily intake for children is 400, for adults 100. Toxicity of vitamin D symptom, hypervitaminosis is present by hypercalcemia. Vitamin K. Vitamin K is fat-soluble vitamin which is necessary for the maintenance of prothrombin, a key substance in blood clotting. The molecular action of vitamin K remains an enigma, but apparently it acts in the liver in the synthesis of protein concerned with clothing. Dietary source. Vitamin K is ubiquitous in human foods through in very small amounts. Most vitamin K is absorbed after being synthesized by human bacterial flora. Dietary deficiency in men rarely occurs. deficiency. Also, there has been considerable debate. It's now generally believed that vitamin K administration to newborn infants decreases the incidence of neonatal hemorrhage. This is especially true in premature infants or newborn with anoxia. A single parenteral dose of 1–2 mg of vitamin K or one of its analogs is recommended immediately after delivery. The most serious complication of vitamin K deficiency in infancy is cerebral hemorrhage. Some suggest that the incidence could be greatly reduced by the routine administration of vitamin K to women during the last 2 months of pregnancy. Thanks for attention.